Hello, my name is Parchitri and today I'm going to tell you about the function generator. So here we have a standard function generator. It's 1 megahertz multi-waveform signal generator model MSGM1M. Breaking down the whole name, 1 megahertz, that means it can go up to maximum value of 1 megahertz. It can generate a waveform up to 1 megahertz. Next is multi-waveform because it can show three types of waveforms: sine wave, square wave, and triangular wave. And waveform signal generator because it generates the AC signal, and then we can use it, we can supply it to any uh, circuit we want. Model is MSG1M. It's a basic and standard function generator. We'll start from we'll start from the probes. So we have to connect one probe to the function generator, which is 50 ohms, which has a resistance of 50 ohms, and connect it to the DSO, the channel 1 of DSO. Here you can see I've connected to channel 1 of DSO. Okay. Now we'll talk about the buttons and knobs from 1 to 8, and I will be explaining all of that stuff. So don't worry about it. Now you'll be wondering what this button is and why is it just alone. So this button is to adjust the frequency. But if you want to adjust the voltage along with the frequency, this frequency generator also supplies voltage as well. So we can just do it with the touch of a button, tap of a button. So now it is on voltage. When we press it, it's on voltage. When it's outside, it's on frequency. So I have pressed it, and now I can adjust the voltage using this knob called level knob. So here you can see it becomes 19.1, 18. We can let's see how minimum we can go. We can go minimum up to 1.93 in this function generator, and maximum up to 20.9. So we'll give it maximum for right now. Now we'll switch to frequency. Now let's talk about this box. This box, we have two knobs and many buttons. Okay, so let's start with the buttons first. So the buttons give us the maximum frequency it can reach, starting from zero point 0.1 hertz, and it goes up to 1 megahertz. So hence we can prove that, as this name suggests, it can go maximum up to 1 megahertz. So if I press 1 megahertz, you can see, like, if I increase it, it's 1 megahertz. Yeah. And suppose now I will we can change it to 100 kilo ohms, 100 kilohertz, 10 kilohertz, 1 kilohertz, 100 hertz, 10 hertz, 1 hertz, 0.1 hertz. We will stay with the standard, that is 1 hertz. So 1 kilohertz rather. This shows 1 kilohertz. Now I can see the value is not that precise. I want exact 1 kilohertz. So rather than just having, if I want 1 kilohertz, rather than just having 1 kilohertz, I'll keep it 10 kilohertz, so that I can reduce it. If I can't reduce it to 1 kilohertz, then I will go switch back to 1 kilohertz. So I switched to 10 kilohertz. It's 13 kilohertz right now. I just did this using the coarse knob. The coarse knob, there are two knobs, like of the knobs. The first knob, that is the coarse knob, it adjusts the value, high value. Like if I want to go from 13 to 1, so I can't just keep on spinning it, going lesser, like 0.001. I can't go decrementing 0.001, 0.005. I want to decrement it fast. Hence, I will use the coarse knob. And using the coarse knob, as you can see, I fell down to 307 hertz. We will go. I feel this value is satisfied. Now I want precise 1 kilohertz, and it's showing 1.028 kilohertz. If I want precise, I need to change the fine frequency. So how will I adjust the fine frequency? So we have a knob for fine frequency. The second knob is for fine frequency. Now, as you can see, as I am changing it, the frequency here is decreasing by 0. By a decrementation of 0.001 kilohertz. And as you can see, as I'm decreasing, and here it is. We have the exact value of 1 kilohertz. So now, as I explained this one, now we'll go into the other half of the function generator. Yeah, we have various knobs and various buttons. Now these all buttons have different functions. And now on this DSO, you can see the sine wave. Suppose I want square wave or triangular wave, I can do that. I can just do it with the press of button. So here there are three buttons. Sine button, sine, it shows sine wave. It gives a triangular wave and it gives a square wave. So I'll press on the triangular and you will see the changes on the DSO. See it? Next, we'll go on to square wave. You can see the changes here, and here also you can adjust the frequencies. There's no worries in that. Adjust the frequencies as you want. So I'll keep it to 1 kilo. Yeah, approximately 1 kilohertz. So that's fine, I guess. Okay. Now we move on to the other buttons and other knobs. Now here is I will switch back to sine wave because that's the standard wave which we use usually during AC signal, giving AC signal to any circuit. Now we start about the symmetry. We have the symmetry button here. Now, yeah, as you can see, I have put a square wave here because square wave it will be better for square wave to show symmetry. Now, if I press symmetry here, it's you think it's zoomed in, but it's not zoomed in. It's because the frequency has fallen down so low that the time period is too longer. Hence, it shows a big wave. So, I'll just increase the frequency for better understanding. Now, as you have seen, that this is an asymmetric curve. Usually, this is at the time it takes to propagate the crest is the same time at same time it takes to propagate the trough. But if you want to change it, or if you want the crest to go more and the trough to go less, propagate for a less time, we will use the symmetry button. If we increase, we can increase the gap between them. How much time we need for it to propagate. So that's done. I will adjust it back to its original state, how it was, setting it to 10 kilohertz and increasing it to about 1 kilohertz. Yeah, I'll switch back to sine wave. Now we have two more knobs and two more buttons to go. We have DC offset. What is DC offset? Suppose I want to, like, usually sometimes the supply is just DC, not just DC or just AC. There can be we can have a supply of AC plus DC. Now how does a supply of AC plus DC looks like? AC wave is sine wave, but when we add DC into it, we can propagate the whole graph upwards or downwards. For that we can use the DC offset. Now, as you can see, I am propagating the sine wave graph upwards, and if I go towards the negative side, I can propagate the graph downwards. Yeah. So hope that is clear. And last but not the least, we have attenuation. In attenuation, we have two buttons and one knob. What does attenuation do? We have two buttons. It shows 20 decibels, 40 decibels, and 60 decibels. Now, suppose if we want the wave to be very much smaller, but we can't go much smaller because of the DSO or because of this. So rather than that, we want to keep the frequency same, but we want the wave to be smaller. We can do that using attenuation. If I press the 20 decibel button, you can see that the wave has become so small, and I can show you. Hmm. The frequency has not been changed, but the wave has been shortened using attenuation. Uh, if you see here, you will see that the wave has not changed, but the wave has changed. I have changed the volts per division grid using this button here. So if I keep the usual grid, I get this graph. And for 40 decibel of attenuation, I can get a much smaller than the 20 decibel one. And if there is also another option to press both of them together, 20 and 40, which add up to 60 decibels, and it shows an attenuation of 60 decibels. Yeah. So if I adjust this, it's very small, so I can't adjust it anymore. Now, if I adjust the horizontal one, even that I can't adjust because it's too small. So that's that. So you close that, and you can see it has come back to its normal form. And I had changed the grids because I had to decrease it so that I could adjust the sine wave. And so this is how a function generator works.